In this lesson, we will be simplifying cubes. Do you still remember the key questions? So Zoot and his Rubik's Cube. What about cubes? Yes, I know. So first know the first 5 perfect cubic numbers. So why is 1 a cubic number? Because 1 times 1 times 1 is 1. It forms a cube. Which of these numbers, cubic numbers, will be represented by this cube? Well done, 27, because there are 27 little cubes. 3 times 3 times 3. Length times breadth times height. It forms a perfect cube. So these are just numbers representing per. Let us revise. Example number 1. 3x cubed means 3 times x times x times x. Note, it's just the x that is being cubed, not the 3. The 3's exponent will be 1. What if 3x is in brackets cubed? Yes, then the 3 is also being cubed. 3x times 3x times 3x. Use the commutative property and multiply the 3 by 3 by 3, and that is 27x cubed. What if we've got this cubed? Now remember your laws of exponents. 3 must be cubed. X cubed must be cubed. There's a power being raised to a power. What is the law again? Yes, you are right. We multiply the exponents. If you don't know the law, you'll have to write it in expanded form. That's too much work. So let's know our laws of exponents, right? So what about negative numbers? Do you still remember that negative x squared and what happens? It becomes a positive. So what happens if we've got negative x cubed? So this means we subtract an x cubed. So the answer will stay negative x cubed. What about negative x in brackets cubed? Negative x times a negative. So the negative is multiplied by itself 3 times, not just like here once. But coincidentally, this is still a negative because of the fact that there are 3 negatives that are being multiplied by each other, not just one. So this case and this case is negative. Note, when it was negative x in brackets square, it became positive. Now it stays negative. So negative x cubed, and the cube is inside the bracket, it will be the same as this first one. There's 1 minus, and x is cubed, so it stays negative x cubed. But what if we have subtract a negative x that must be cubed? So we first cube the negative x, and we know that is the same as negative x cubed. But then we have to subtract the negative x cubed. So the answer is then positive. Be careful. Zoot, what he did, he said negative times a negative is a positive. And yes, he will get the right answer. But the way that he got his answer is wrong because he didn't follow order of operation. He's very lucky that he got it right. And if I had to ask him to prove it, he would get it wrong. Because you first have to cube and get an answer, and then you subtract that cubed answer, and that will give you a positive. Here is a common mistake when we deal with 2 expressions in brackets cubed. You cannot cube each term separately. You can only use the laws of exponents if this is one term. There are 2 terms. So this is a big mistake. We first have to simplify the bracket. Oh, I knew I'd have to prove it again. Okay, I will. Let's just use easy numbers. So if we've got 2 plus 3 in brackets cubed, and if we want to do this, cube each term separately, we will get 35. But if we first follow order of operations, because we can, when we calculate the bracket, we will get 5. And 5 cubed is 125. And the 2 answers are not the same. So one of them is wrong. Which one is wrong? Yes, the left side. So you cannot cube separate expression, separate terms in a bracket. It must be one term. So there are 2 terms. So we have to first simplify the bracket before we can cube. This is 10x. If we cube it, remember to cube each number in the bracket because this is now multiplication. This is one term. So you then can cube each number separately. 1000x cubed. What about this one? If we've got a negative in brackets cubed, remember a negative cubed is negative times a negative times a negative, so it stays negative. Do you remember when it was a square? Then it will become positive, but with cubing, it will stay negative.